students, so here we are with the question first of the exercise 4.4 for the chapter Quadratic Equations. So the question first is, find the nature of the roots of the following quadratic equations. If the real roots exist, find them. And the three quadratic equations have been provided in part 1st, 2nd and 3rd. So the first step we need to follow is to find the nature of the roots of these very quadratic equations. And if their nature is real, that is, we obtain the real roots, then we need to find what the real roots are for each quadratic equation. So the steps we need to follow is to first compare this quadratic equation with the standard quadratic equation. And what is the standard form of the quadratic equation? Ax square plus bx plus c is equals to 0. So this is the standard quadratic equation. From here, we need to find the discriminant of each of the quadratic equation. And what the discriminant is, discriminant of any quadratic equation is equal to b square minus 4ac. That is, if we substitute the value of b, a and c of any quadratic equation in this formula, then the answer which we get is the discriminant of that quadratic equation. Now, the next step will be, if b square minus 4ac, that is discriminant, is greater than 0, then two distinct real roots exist. Means if for any quadratic equation the discriminant comes out to be greater than 0, then we will definitely be obtaining two distinct real roots from that quadratic equation. But if the discriminant, that is if b square minus 4ac is equals to 0, then two equal real roots will be obtained. Means if the value of the discriminant of the quadratic equation is equal to 0, then there exist two equal real roots. What if discriminant, that is b square minus 4ac, comes out to be less than 0? Then in that case, no real root exists. That is, we cannot obtain real roots for that very quadratic equation if its discriminant value is less than 0. So this was about the information that how we can conclude that whether the given quadratic equation have real roots or it don't have any real roots. So starting with the first quadratic equation being provided, so the first quadratic equation is 2x square minus 3x plus 5 is equals to 0. Comparing this quadratic equation with the standard quadratic equation form, so here the value of the a is 2, b is equals to minus 3 and c is equals to 5. So if we find the value of the discriminant, so for this quadratic equation, discriminant has a value, that is b square minus 4ac. So substituting the value of the b, a and c in that formula, so here I'll be getting minus 3 square minus 4 into 2 into 5, which comes out to be equal to minus 31. Clearly the value of the discriminant is, that is b square minus 4ac is less than 0. Right? And if we see this information which was given earlier, if the value of the discriminant is less than 0, then that quadratic equation has no real roots. So we can conclude over here that therefore no real roots is possible. That is, we cannot obtain the real roots for these quadratic equation. And if the real roots don't exist, then we cannot proceed further to find the roots, which is very clear. So now coming to the second equation, here the second quadratic equation being provided is 3x square minus 4 root 3x plus 4 is equals to 0. Comparing this quadratic equation with the standard form, the value of the a is 3, value for the variable b in that standard form will be minus 4 root 3, and the variable c has the value 4. So the discriminant, if we find for this very quadratic equation, its value comes out to be equal to b square minus 4ac, which will be equal to minus 4 root 3 square minus 4 into 3 into 4. So on solving, I'll be getting the value 48 minus 48, which is equals to 0. That is, the discriminant has a value 0. And we know if the discriminant has a value 0, then two equal real roots exist. Means, therefore, real roots are equal for this quadratic equation. So now, as we know the real roots exist, we need to find those real roots. So the method to find the roots which are equal are, and the roots will be minus b over 2a and minus b over 2a. That is, if there comes a case when the discriminant is equal to 0, then in order to find the real roots, the formula is minus b over 2a. Substituting the value of the b and a over here, so this will be minus b over 2a is equals to minus into minus 4 root 3 divided by 2 into 3, which comes out to be equal to 2 root 3. So these are the two equal roots of this quadratic equation. So therefore, roots are 2 root 3 and 2 root 3 respectively. Okay, now coming to the third quadratic equation. So here the quadratic equation being provided is 2x square minus 6x plus 3 is equals to 0. Comparing this with the standard form, here the value of the a is 2, b is equals to minus 6 and c is equals to 3. So if we find the discriminant of this quadratic equation, so discriminant, that is b square minus 4ac will be equal to minus 6 square minus 4 into 2 into 3, which will be equal to 12. Clearly, b square minus 4ac is equals to 12 means greater than 0. So if discriminant is greater than 0, we know, therefore, distinct roots exist. That is, if discriminant happens out to be greater than 0, then definitely for that quadratic equation, distinct roots exist. And how we can find the distinct roots? By using the quadratic formula. What was that? Minus b plus minus root b square minus 4ac divided by 2a. Okay. Now substituting the value of the a, b and c in this formula, here it will be minus into minus 6 plus minus root minus 6 square minus 4 into 2 into 3 divided by 2a, that is 2 into 2. So if we solve this, it will be equal to 6 plus minus root 12 divided by 4, which can also be written as 6 plus minus 2 root 3 divided by 4. If we take the signs separately, plus minus, and also cancels the common term from the numerator and the denominator, so here I'll be getting 3 plus minus root 3 divided by 2. Therefore, the roots of the third quadratic equation are 3 plus root 3 divided by 2, and the second root is 3 minus root 3 divided by 2. So these are the two distinct roots of third quadratic equation. So this was about the question first of the exercise 4.4. I hope this question is clear to all of you.